Let's have a look at question 13. So this is a integration by substitution question, and they already gave us the substitution. So let's start this. X is equal to a sine square theta. So then first I will change the limits into theta value. So if x1 is equal to a, so that means a equal to a sine square theta. So that means divide by a for both sides, and we have sine square theta equal to 1. So then sine theta is equal to 1. So theta is just equal to pi over 2. And then x2 is equal to 0, which means 0 is equal to a sine square theta. So then sine square theta is equal to 0. So divided by a is 0 divided by a is still 0. So therefore, sine theta is also 0. Then theta is 0. So that would be the upper and lower limits. And then differentiate x equal to a sine square theta. So that means dx over d theta is equal to, bring down the power, minus 1 the power, and then because this is sine theta square, so it's not x square, sine theta square. So that means the sine theta here would be the chin. So we just have to times by the derivative of chin. So sine differentiate to cos theta. So that will be our dx over d theta. And then rearrange that. Dx is equal to 2a sine theta cos theta d theta. Okay, now we can do the substitution. So a0 x part half, and then square root of a minus x dx. So first we change the limits into theta value. So the upper will be pi over 2 and lower will be 0, which we already got in here. And then x part 1 half root a minus x times by dx. And then we know dx is equal to 2a sine theta cos theta d theta. So we change that. So 2a sine theta cos theta d theta. So now we just have to find a way to simplify it. So I will take out 2a. So then that'll be 2a pi over 2, 0. And then put the substitution in. So if x equal to a sine square theta, then x part half would just be square root of a and then sine theta. Just square root each one of them. So root of a, just root a, and then root sine square theta, just sine theta. And then square root of a minus x, which is a sine square theta. And then sine theta, cos theta, d theta stay the same. And then keep simplifying. So 2a, and then pi over 2, 0. And then root a. So sine theta times sine theta, that would be sine square theta. And then square root of a minus a sine square theta would be a times by in brackets 1 minus sine square theta. If we factorize out a, and then cos theta d theta. So then that would be 2a pi over 2, 0. Root a sine square theta, and then square root of a times by cos square theta, and then cos square theta, then cos theta d theta. So that will be 2a pi over 2, 0, and then root a sine square theta, root a sine square theta, and then square root of a cos square theta. So square root each one, root a just root a, and root cos square theta, that would be cos theta, and then times by another cos theta would be cos square theta d theta. So now we have 2a, root a times root a is just a, so that would be 2a square, and then pi over 2, 0, sine square theta, cos square theta, d theta. So The final expression was sine square 2 theta, so that's fine. We can use the double angle formula. So because we know the double angle formula is sine 2 theta is equal to 2 sine theta cos theta. So that means sine theta cos theta would be sine 2 theta over 2. So that's what we're going to use to change that into sine square 2 theta. Yeah. So if we apply this, so we can change that into 2a square pi over 2 0 sine theta cos theta all square d theta. And then because sine theta cos theta we already know is sine 2 theta over 2, so we can change that into 2a square pi over 2 0. So sine 2 theta over 2 all squared d theta. So which is 2a square pi over 2 0 sine square 2 theta over 4 d theta. So then took out 1/4. So 2 times 1/4 is just 1/2. So we have a square over 2 pi over 2 0 and then sine square 2 theta d theta. So that would be the answer for part A. Okay, and then for part B, we need to actually integrate it to get into that form. So let me show you how it works. So for part B, if we want to integrate this, we already use substitution to change into that form. So we just have to continue from here. So 1 over 2a square pi over 2 0 sine square 2 theta d theta. So every time when we integrate sine theta square or cos theta square, we always use the double angle formula for cos. So because this is sine square 2 theta, so the double angle formula we should use is cos 4 theta equal to 1 minus 2 sine square 2 theta. Because it's double angle formula, whatever this angle is, this one should be double of that. And that's what double angle formula means. Yeah. So since this is sine square 2 theta, so then it has to be cos 4 theta. So then rearrange that, we can like plus 2 sine square 2 theta for both sides, and then minus cos 4 theta for both sides. So then sine square 2 theta just 1 minus cos 4 theta over 2. So now if we apply that to this question, so we have half a square pi over 2 0, and then sine square 2 theta is 1 minus cos 4 theta over 2 d theta. So took out 1/2 as well, and that'll be 1/4 a square, and then pi over 2 0, 1 minus cos 4 theta d theta. So then integrated 1 will integrate to theta, and then cos 4 theta will integrate to sine 4 theta over 4, and then with the limits pi over 2 and 0. So then a square over 4, so big brackets, so that'd be pi over 2 minus, so sine 4 times pi over 2, so 4 times pi over 2 is 2 pi, so sine 2 pi should just be 0, so we can just put 0 here. And then minus 0 minus sine 0 is also 0, so all these terms will become 0. So it's really just a square over 4 times by pi over 2. So that will give us, they want k pi a square. So our k should be 1 over 8, because 4 times 2 is 8, and it's in the denominator, so it's 1 over 8. And then pi is still pi, and a squared is a square. So in this case, k should be 1 over 8. Let's have a look at question 7. Figure 2 shows a cylindrical tank of height 1.5 meters. Initially, the tank is full of water, so the water starts to leak from a small hole at a point L.
in the side of the tank. So, which is point L here. Okay. While the tank is leaking, the depth H meters of the water in the tank is modeled by the differential equation dH over dt equal to negative 0.12 e to the power negative 0.12 t. So where t hours is the time after the leak starts. So be careful with all the units. So t is in hours and h is in meters. And then using the model, A show that H equal to A e to the power negative 0.2 t plus B, where A, B are constants to be found. Okay. So for part A, we just have to integrate dH over dt equal to negative 0.12 e to the power negative 0.2 t. So for this one, we don't have to use separation of variable because the expression on the right-hand side is just in terms of t. So there's no h in it. So we don't need to do separation of variable. We just have to integrate straight away. So h is just the integral of negative 0.12 e to the power negative 0.2 t dt. So that means h is equal to negative 0.12 is the coefficients stay the same. And then since this is just a linear expression, so just e to the power negative 0.2 t, and then divide by the coefficient of t, which is negative 0.2 plus c. So simplify that, h equal to negative over negative cancelled, and then 0.12 divided by 0.2 is equal to 3 over 5. So h equal to 3 over 5 e to the power negative 0.2 t plus c. And now we need to find out the value of C. It says initially the tank is full of water. So that means when T equal to 0, so the cylinder tank of a height 1.5 meters. So if it's full of water, that means the height of the water should be 1.5 meters. So H equal to 1.5. So then substitute in h equal to 1.5 and then t equal to 0. So that would be 1.5 equal to 3 over 5. And then e to the power 0 is just 1 plus c. So c is just equal to 1.5 minus 3 over 5, which is equal to 0.9. So then h equal to 3 over 5, which is 0.6. Let me just change it all into decimal. So 0.6 e to the power negative 0.2 t, and then plus c, which is 0.9. Then that'll be the final answer for part A. It's only 3 marks. Okay, part B. Find the time taken for the depth of water to decrease to 1.2 meter. Give your answer in hours and minutes to the nearest minute. So for part B, we want to work out time when t time, yeah, which is t. So when the height become 1.2 meter. So we just let h equal to 1.2. So 1.2 equal to 0.6 e to the power negative 0.2 t plus 0.9. So minus 0.9 for both sides, that would be 0.3 equal to 0.6 e to the power negative 0.2 t. And then divide by 0.6. So 0.3 divided by 0.6 is just equal to 1/2. So 1/2 equal to e to the power negative 0.2 t. So that means negative 0.2 t is just equal to ln of 1/2. So, and then 0.2 t should be the same as ln 2 because ln 1/2 is negative of ln 2. And then, so t is just equal to, so 5 ln 2. So because divide by 0.2, 1 over 0.2 is equal to 5. So 5 times by ln 2, put in the calculator, we have t is equal to 3.46573, and then the units would be hours. But be careful about what they're asking you. So give your answer in hours and minutes to the nearest minute. So then that should be 3 hours. And then we need to change 0.46573 hours into minutes. So it comes by 60 for 0.46573. So that'll be 27.94. and they want to the nearest minute. So 27.94 is just 28 minutes. So then that will be the final answer for part B. So that's another 3 marks. And then part C, in the long term, the water level in the tank falls to the same height as the hole. So part C, find according to the model, the height of the hole from the bottom of the tank. So basically, it's just asking you what's the limiting height. So if we let t goes into infinity, so that means either part of negative 0.2t will go to 0. Because either part negative 0.2t will goes something like this, the diagram. So as t get bigger, it'll get smaller and smaller, eventually turns to 0. So which means h should turns into 0.6 times 0 just 0. So it just plus 0.9 is just 0.9. So that means the height of the hole from the bottom of the tank should be 0.9 meters.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.